I base my talk on a collection from Norway's Water Resources and Energy Directorate that documents glacier measuring in the 1950s, 1960s, and 1970s. So, firstly, I would like to set the mood. In a primitive triangular cabin high up in the Norwegian glacier of Folgefonna lie two people, young people listening to the storm howling out there. Even though it's still summer, now in the beginning of September 1968, the weather is capricious here high up and far west in Norway. The young people know that they have work tasks ahead, but realize that in this weather it's dangerous to move outside the cabin. Precipitation and water flow shall be measured and stakes shall be drilled in the ice. And the two field assistants have been able to borrow a camera from NVE, the Norwegian Water Resources and Energy Directorate in Oslo. As soon as the weather allows, the young people are ready to take up their work tasks again. And at the same time, they document with the camera. They record weather, temperature, runoff, and snow growth. They measure water flow, sediment transport, and how much the glacier grow or recede. And all this was documented using a camera. The cameras seem to primarily capture the work that was carried out, as well as changes and characteristics of the glacier's properties and topography. However, a review of the material created during this period shows that the glacier observers also focused their attention on everyday life and nature experiences, a distance from the strictly measurable tasks they performed on the glaciers. The contrast to previous photographic documentation made in connection with the glacier measurements is relatively large. Work carried out by the Norwegian Polar Institute from 1949 to 1962 shows a stricter instrumental approach to the use of photography. Here, production was concentrated around measurable glass plates made according to the so-called photogrammetric method, which in short means using measurable photographic images to determine geometric properties such as shape, size, and location of objects. However, NVE has not used measurable photos in its own measurement, research, and management of Norwegian glaciers. Instead, NVE's glacier office in the hydrological department encouraged glacier observers to and field assistants to take pictures either with their own cameras or with borrowed cameras from the office in Oslo. It thus seems that NVE did not see the benefit in taking measurable pictures in the tradition of, among others, the Polar Institute. So NVE's glacier images show a clearly looser connection to the scientific work that was carried out in the glaciers. The use of the cameras and photographs that were produced largely reflects everyday life and experiences in addition to seemingly building around the scientific purpose of the work. So assuming that the impressions of NVE's glacier images in contrast to other photographic documentation is correct, a number of interesting questions arise. How and why can science treat the photographic medium so differently? What does it say about the relationship between photography and science? And what does such an approach say about the inherent properties of photography? These are questions my project is investigating. The role of photography in science is, of course, interesting precisely in the meeting between science's need for objectivity and the malleable, unfaithful medium of photography. So NVE saw significant hydropower potential in the runoff from the Norwegian glaciers and wanted to initiate systematic measurements and investigations on the most interesting glaciers. And these surveys were about measurements of mass balance on the Jostedalsbreen glacier, the biggest in Norway. Mass balance means the difference between how much the glacier grow in the winter due to precipitation and how much they decrease in the summer due to melting. So later, measurements of drainage and sediment transport were also included. It turned out that particles in the meltwater led to wear on the turbines on power plants. The need for strong industrial growth after the Second World War also led to a parallel need for power in Norway. Large and energy intensive industry was to be given priority, and the state as developer was given a central role in this work. The industry's consumption of electricity increased formidably in the first years, 84% from 1946 to 1950. And the Norwegian state, represented by NVE, was responsible for most of the post-war major hydropower developments. And the developments also generated better finances for conducting research, and potential was seen in other sources that had not previously been seen upon as possible to exploit. The glaciers were among these. Throughout the 60s and 70s, several glaciologists and hydrologists were employed on the glacier surveys, but the field assistants formed the backbone of this field work. These were often students who were interested in glaciers and outdoor life. In the busiest summers, 20 to 25 people were employed at the same time. And the summers were used for measurements. Employees and assistants first lived in tents, later triangular cabins were set up, simple and cramped, but functional cabins with the necessary equipment. Historically, the link between photography and the science that are relevant in this context has been divided into two kind of camps. On the one hand, the natural science have to a larger extent related to the aspects and approaches to photography that are measurable and that support scientific methods such as terrestrial photogrammetry and oblique photography. The humanities and social sciences have a somewhat greater extent, become interested in the connection between photography and the natural sciences from their own perspectives, for instance, through documentary photography. So photographic documentation related to glaciological and hydrological surveys goes back much further than 1962. In NVE's archives, we find the French glaciologist Charles Rabot's glass plate photos from Norwegian glaciers in the 1880s, and the geologist and polar researcher Adolf Hoel's glacier images from northern Norway. These primarily show a scientific approach to photography with measurable glass plates. In 1949, the Norwegian Polar Institute began with systematic measurements on the Storbreen in Jotunheimen. Throughout the 1950s, until NVE took over responsibility in 1962, the surveys were supported by photographs of a photogrammetric character. So the use of photography in topographical and other scientific contexts is closely linked to the concept of scientific objectivity. This concept is, of course, large and comprehensive, so I choose to concentrate the discussion here on elements where science sets the premises for the photographic medium and vice versa. In its purest form, objectivity is blind without disturbance, interpretation, and intelligence. The requirement of objectivity must support the scientific intentions, which are known to be linked to expectations of results. In addition, there are the necessary elements of human interpretation. For why is objectivity a key concept in the meeting between science and photography? Perhaps because in photographic examples, one encounters notions of scientific objectivity in its clearest form. At the same time, one gradually sees in scientific photography the necessity of the actor as sender and receiver with his intentions and interpretations. The ideal of the Enlightenment to be true to nature and to seek truth presupposed that the observer had the right qualities with a combination of a sharp and critical eye and the ability to opt out of insignificance. The model of science was then the experienced and qualified researchers' selection of ideal forms in the tradition of Plato. Such an approach was in many ways not compatible with the photograph's loose connection to visual reality. So from about 1860, the call was "let nature speak for itself." The idealized norm from earlier was rejected in favor of the researcher retiring, resisting the temptation of aestheticization and simplification, and then leaving the arena to the mechanical objectivity and thus the image and its new tools, including photography. Machines could thus perform tasks that would otherwise have revealed human weaknesses, such as routine tasks over time. The machines also had no inclination to theory and speculation. You could trust the machines, you could trust the camera. The historians of science, Lorraine Daston and Peter Gallison, distinguish a third path in scientific objectivity, the professional judgment. In this phase, a comeback was seen for the researcher's gaze through the interpreted image, where interpretation and the self form the stem, but in pair with the mechanical image. The incorporation of photography into this type of scientificity required, among other things, a conscious, specific, and procedure-driven use. Here we can jump to Norwegian Glaciers in the 1960s, where the specific use of the medium about 100 years later has abandoned such principles. NVE's glacier photographs do not appear to be particularly conscious, specific, or procedure-driven. Rather, the use of the photographic medium in this context is governed by chance, individual judgment, and emotion. In the middle of the 19th century, subjectivity was seen as a danger to true scientific knowledge, while after the paradigm shift towards a focus on professional judgment, subjectivity has become something of a prerequisite for scientific activity. And here comes the perfect medium to represent the transitions and paradoxes between belief in mechanical objectivity and infected by judgment. Namely, photography, a genus faced between mechanical and will-less depiction of reality on the one hand, and the countless subjective dependencies of photographer, context, society, and receiver on the other. So objectivity is practical, in practical contexts, is particularly interesting here in relation to the expectations science had of photography's ability to depict the sensible world objectively and accurately. Well, although this suggests a consensus on what photography could be used for in science, the consensus was not as strong as to whether the medium could be said to represent objectivity. And furthermore, the perception that photography can never free itself from its mechanical and reproductive starting point has been strong. What some theorists, including Walter Benjamin, call the magical aspects of photography, refer to the guarantee that the image represents the object, and that higher technical quality reinforces this guarantee. The identity of the photograph is thus eternally connected with and to its origin. Such a strict connection between technical quality and objective imagery deprives those photographs with this connection is more obscure, the link to the subject. In this interpretation, NVE's glacier images cannot be said to represent the object. A more nuanced approach is based on the trace of motif that is the result of the mechanical process, where the photograph does not become a truthful motif, not a truthful image, but a trace of someone who has disappeared. An analogy of this may be that the glacier photos here dictate further beyond the measurable reality and bring in other aspects that are not necessarily part of the researcher's goals. In this way, it can be said that the small image camera with roll film per se implies a great and radical freedom in documentation and imagery, and fails the scientific intention behind glacier measuring. By equipping the measurers with these cameras paired with a lack of clear instructions on what to document, a kind of monster has been unleashed, and NVE is left with large amounts of archival material that they did not know or know what to use for, except from undefined desires for use in publications and dissemination. So without defined goals and instruction, the subjective, aesthetic, associative, poetic, humorous, in short, human, sneaks in right away and creates a necessary counterpart. The way we have been accustomed to thinking about the materiality of photography has been through the original paper copy, closely linked to authentic and aesthetic values. From this perspective, it's possible to distinguish between different layers of materiality and again, different layers of representations. From the slightly yellowed photocopy made by one of the iconic photographers from the 19th century to the digitized negative, where dust and marks have not been retouched away. The latter example is like the glacier photographs, available to the public via digital representations. In this form of display, marks and dust are also digitized, and the material thus appears as digital interpretations. The form and way in which the pictures are read will differ clearly from the materiality one is facing and the material context in which they are read. So several of the glacier images is also taken in low light and under difficult conditions, which made the contrast between what was experienced and what was visualized extra strong. In the analysis of photography in the service of science, the media-specific factors are important. And apart from grayscale and color, other characteristics can also be treated on the basis of the same paradox: small image format, dust, fingerprints, chemical stains, mechanical damage. All of these factors that interfere with the ideal of scientific clarity and that draw attention in the direction of the materiality and limitations of the photo medium. Furthermore, other factors refer to the rise in the level of professional skill, exposure, composition, choice of motive, in short, utilization of the possibilities of photography. It can also be argued that weather is an important factor in the analysis of glacier images. For example, there are restrictions for shooting oblique photos and photogrammetry in wind and precipitation, while documentation using small format cameras is possible, albeit with a different result. If you put skill in photographic technique into the calculation, the ideal of nature's own image quickly crumbles. It seems like in order to approach an objective ideal, one must master all aspects of the photographic process as best as possible. This in turn means that the most talented scientist must, by definition, be the most skilled photographers. Of course, this is not the case. On the other hand, even the most talented researchers are not the most talented artists. This argumentative refutation shows that the photograph can hardly be said to represent any ideal of objectivity. Likewise, the argument shows that the idea of a clear distinction between man and science is artificial and perhaps represent more a desire for reality to be clear and understandable. Also, the perspective of photography, as in the photographer's viewpoint, is important as an example of the contradictory relationship that science has had to photography as objective documentation. A prosaic example is that a photo point limited to 1.5 to 2 meters above the ground, that is the photographer's physical height, should be perceived as an objective representation of what one seeks to document. So terrestrial photogrammetry thus has a starting point that is exclusively practical and which one can claim has little to do with scientific photography. objectivity, sorry. This limitation stands in stark contrast to science's ideal goal of freeing itself from one specific perspective, and thus becomes a factor that science must relate to. So impurities, of which the glacier images certainly contain a part, can be claimed and are due to both nature and man as actors. Dust particles, hair, chemical stains, Newton rings, mechanical damage, double exposures, fingerprints. The subject, that is the photographer, and unwanted factors leave their mark physically and to interfere. This sensitive negative material is in many cases makes fun of in practice futile goal of so-called pure imagery. So it's possible to claim, based on preliminary findings set up against theoretical perspectives, that the glacier images are in many ways in a no man's land between science's demands for objectivity and art's embrace of subjectivity. Used as apparent support for research work, these documentary images satisfy neither the radical scientific requirements nor the requirements for free interpretation that, for instance, art sets. In addition, small format photography offers a per se inaccurate documentation. The photograph presents itself as neither one nor the other, neither an authentic depiction of details nor an individual subjectivism. The consequence is this relative ambiguity in the use of an important documentation medium has had for the starting point of the glacier measurements, namely the potential the various glaciers had for Norwegian hydropower development, is kind of difficult to indicate. The hydrological and glaciological measurement methods seem to have constituted a sufficient basis for decisions, and thus the management of Norwegian water and energy resources. So in this context, photography has a possible but largely unresolved role as part of the whole in dissemination, cultural history, and as comparison and documentation of changes over time. When digitized files can now be placed in new context 50 years later, it can provide new opportunities to see where the no man's land is and how the connection between photography and science could be. Thank you.